Let f of xy will be equal to 2, 0 less than x, y less than 1 and x plus y will be less than 1. Then the conditional density of x given y is equal to 0.5 denoted by f of x given 0.5 will be. That is, f of xy is given. F of xy is given as 2. We have to find out f of x given 0.5. So we know that f of x given 0.5 is equal to f of x comma 0.5 divided by fy of 0.5. So in this equation, we can find out fy of 0.5 by integrating over this value f of xy is equal to 2, and we will get the answer. The final answer will be f of x given 0.5 will be equal to 2 for the range of x from 0 to 0.5. That is, option 1 will be the right answer. Next question, let probability of x equal to x, y equal to y is equal to 1 by 12, x equal to 1, 2, 3 and y is equal to 1, 2, 3, 4. The conditional probability that y is equal to 2 given that x plus y less than or equal to 4 is, that is, the conditional probability is given as probability of x comma y is equal to 1 by 12, and we have to find out x plus y less than or equal to 4. So we have seen similar problems how to find the probability of x plus y less than or equal to some number. We can simply change we can integrate probability of xy over the values of x and y, but we have to make some changes since x plus y less than or equal to 4, and if we make those changes, we will get the final answer as second option, that is 1 by 3. Let x1, x2, etc. xn be a random sample of size n from a uniform distribution on the interval 0, theta. Then the uniformly minimum variance unbiased estimator of theta is. That is, in the question, x1, x2, etc. xn is a random sample of size n from uniform distribution with the interval 0, theta. Then we have to find out the UMVUE for theta. So this is a direct question and the answer will be the first option, that is n plus 1 by n into x of n, that is nth order of x. So first option is the right answer. Next question, let y1, y2, etc. yn be IID random variables of size n from a distribution with a density function. F of y alpha is equal to 2 alpha square divided by y cube if y greater than alpha and 0 otherwise, where alpha greater than 0 is unknown. If ya is the ith order statistic, then the maximum likelihood estimator for alpha is. So we have to find out the MLE of alpha. So we can see that the density function is given by fy of y comma alpha is 2 alpha square divided by y cube. So we can take likelihood of alpha as L of alpha is equal to f of y1 comma alpha into f of y2 comma alpha etc. till f of yn comma alpha. So this we will get as 2a square divided by y of 1 cube all raised to n. And this L of alpha, that is likelihood of alpha, will be constrained to the only one, and this likelihood L of alpha will be constrained to only one condition, that is a will be less than or equal to y of 1. So since we already have the likelihood equation, we will maximize it and equate it to 1, and finally we will get the maximum likelihood estimator as y of 1. So second option will be the right answer. Let y be an observation from population with the density function. F of y is equal to theta square y into e power minus theta y if y greater than 0 and theta greater than 0 and 0 otherwise. If chi-square n alpha is the alpha the lower quantile, for testing h0 theta equal to 2 against h1 theta equal to 1, the most powerful test of size alpha is given by reject h0 if y greater than k, where k is given by, that is, the chi-square n alpha is given as the alpha the lower quantile for the given density function theta square y e power minus theta y. And the test that we are going to test will be h0, that is null hypothesis is theta equal to 2 and alternative hypothesis is theta equal to 1. Now the MPT, that is most powerful test of alpha, is given by reject h0 if y greater than k, and we have to find out what is k. So the null hypothesis we took as theta equal to 2, and if we are going to reject h0, that theta is equal to 2, So if we have to reject h0 if y greater than k, the value of k will be given by 1 by 4 chi square 4 comma alpha, that is 1 by 4 into chi square with the degrees of freedom for n is equal to 4 and size is equal to alpha. This will be the right answer. Option 1 will be the right answer. Let y1, y2, etc. yn, yn plus 1 be a random sample from a normal theta, 1 population. If yn bar is equal to 1 by n summation j equal to 1 to n yj and t is equal to 1 by n yn bar plus yn plus 1, then for estimating theta, 4 statements are given. That is, yn bar is given and t, the estimated t is given, and the random sample is from a normal population with the parameters theta, 1. So we have to see which among the statement is correct. So while reading all the 4 statements, we can see that the second option is the right one, that is t is unbiased. See, the estimated t is given as 1 by 2 yn bar plus yn plus 1 and yn bar is already given. So from that we can understand t is unbiased and not consistent. So the option 2 is the right answer. Next question, let f of x is equal to 1 by beta of mn into x raised to m minus 1, 1 minus x raised to n minus 1, where x ranges from 0 to 1. Then the modal value of x with the density function f of x is, that is, the given question is a beta distribution and we have to find out the mod of beta distribution. So this is a direct question and we have already learned the equation to find out the mod as m minus 1 divided by m plus n minus 2. That is the third option is the right answer. Let x1, x2, etc. xn be a random sample from normal theta, 1 distribution. The lower bound for the variance of unbiased estimator for theta will be. Again, we have a direct question. That is, we have a random sample x1, x2, etc. xn from normal theta, 1. That is, sample size will be n. And we have to find out the lower bound for the variance of unbiased estimator, and that will be equal to 1 by 9. Option 2 will be the right answer, that is 1 by 9. Next question, let y1, y2, etc. yn be a random sample from a population with the density function. F of y, theta will be equal to e power theta minus y if y greater than theta and 0 otherwise. And y of 1 is equal to minimum of y1, y2, etc. yn. That is the first order statistic. Then the confidence level for the interval y of 1 minus 2 by n log e5, y of 1 will be equal to. That is, the confidence interval for the first order statistic minus 2 by n log e5, first order statistic will be the first option, that is 0.96 will be the answer.